the easiest to do is if we first calculate the first derivative with respect to x, y, z. So what is the derivative with respect to x going to be?
2xy.
Yes, 2xy.
Plus 2y square.
Plus 2y squared, yes, and this part?
0.
Gives 0, yes. With respect to y?
X square.
X squared.
Plus 4xy.
Plus 4.
Plus 0.
Plus 0.
Yes. Plus
4xy.
4xy. Plus
4xy plus 0.
And f with respect to z?
18z square.
18z square.
Z square. Z square.
Yes, 18z square. Yes. Now let's do that. Here in the first row, we need the derivative with respect to x, and we need to differentiate it further. With respect to x, it's going to be
2y.
2y, yes, because this gives 0. With respect to y,
2x plus 4y.
yes. With respect to z,
0.
yes. Next one. With respect to y,
2x plus 4y.
4y, he's saying, or she? Yes, 4y.
4x.
Yes, 4x. With respect to y, 4x.
Then 0.
Yes.
0.
0, because it doesn't depend on.
Yeah.
Again
Then
0.
0 again 0.
Yes,
36z.
36z. Okay, so this is the Hessian matrix where we have to write the second derivatives of the function. So it depends on 3 variables, so it has 3 times 3, 9 entries. It's a 3 by 3 matrix. Okay, so it has 9 second derivatives. Important.
Ma'am.
Yes?
Ma'am, in Hessian matrix, we always find 2 second derivative.
Always the second derivatives. Yes. Okay. So the second derivatives in the first row, the first step to differentiate it with respect to x and then x, y, z. Yes, but always the second derivatives. Yeah, exactly. Okay, next. Exercise 3, we have x squared e to the sine x. Okay, x squared times e to the sine x. We need to differentiate this function.
So we have to calculate u and v.
Yes,
that
exactly.
means we have to take first x square. That means 2x.
Yes. So why do we need to do that? What kind of function is this?
Multiplication.
Multiplication. Very good.
U and v. U into v. That means
yes.
multiplication.
Okay. You like uv. Okay.
Yeah.
I usually write fg, but we can write uv. So we have a product of 2 functions, u and v. We need to differentiate it. How do we get that? We need derivative of u times v as it is, plus u as it is, and v times derivative of v. Now, let's apply it. So the derivative of this function is going to be, so what is u, what is v? X squared is u, and e to the sine x is v. Okay.
This is e to the power sine x.
So u, derivative of u, derivative of x squared is what?
2x.
2x.
Times v as it is, we don't change it.
Oops.
Plus
X square.
Yes.
X square.
Because we need u as it is, unchanged. Times derivative of v. What is the derivative of e to the sine x?
Cos x.
Cos x e to the power sine x.
Mm-hmm. So, yes. Let me explain it for those who are not sure about this. So, we have e to the sine x. What kind of function is this? we can see that this function is composed of two functions, e to the x and sine of x. So we put sine of x in place of x here, right? So we get a composite function. Composite function that is f of g of x. F of g of x. Okay, f of g of x, where, what is this? G is the internal function. Internal function. What does the internal function mean? Which is the internal function here? Okay, let's say f is the external. So f is the external, g is the internal. What is the internal function in this function? Which is the internal? How do we know which one internal is?
Which we calculate first.
Yes, exactly. So we can see we have g of x, that is, first g is applied to x, that is, if we wanted to substitute a number in place of x, what would we calculate first? E to the x or sine x?
Sine x.
Sine x. Yes, we would do sine x first. So sine x is the internal function. This is g. And the external, then e, because this is what we would, this would be the second step. Yes. So how do we differentiate a composite function? We need to find the derivative of the external function in the place of g of x, multiplied it by g of x as it is, unchanged, and then multiply it by the derivative of g, that is the internal function. So if we have e to the sine x, the derivative is, we said that e is the external function. What is the derivative of e to the x?
It is x.
Yes, it's f. So derivative of f is e to the x, but the x is g of x now. So we need to write sine x, right, in the same place, g of x, times, we need the derivative of g, derivative of sine x.
That means cos x.
Cos x, yes. So I continue here as e to the sine x times cos x. Of course, you can put cos in front. You could have written cos x times e to the sine x, same thing. Yes. So this is how we find how we differentiate composite functions. Okay. Very important. You have to expect this at the exam. So you need to know. Let's do another one. ln 1 plus e to the x squared. ln 1 plus e to the x squared.
1 by 1 plus e to the power x squared.
Mm-hmm. So this is again a composite function. It is composed of ln x and 1 plus e
to the power x squared.
Yes, very good. So which one is the internal function? The internal. So again we have
g to the power x, I think.
f of g of x.
F of g x.
Say it again.
Yeah.
Which one? G is which one?
1 plus e to the power x squared.
1 plus e to the power x.
Yes, exactly. This is the internal function because this is what we would calculate first. And then we would apply the logarithm. So ln is the external function. Okay. We need to differentiate the external function, ln. What is the derivative of ln x? What is the derivative of ln x?
1 over x.
Yes, 1 over x.
1.
Yes, that is the derivative of this, the derivative of this function going to be 1 over
1 plus e x
yes,
squared.
we need the g of x instead of just x. We have
1 plus e to the power x.
Yes. And now we need to multiply it by the derivative of the internal function. What is the derivative of 1 plus e to the x squared? What is the derivative of 1? Sorry?
2x e x squared.
Mm-hmm. So The derivative of 1 is 0.
0.
Okay, so we don't need to deal with. What do we see about this e to the x squared? What do we see? We see that this is again a composite function. So it is composed by e to the x and x squared. X squared is put in place of x. Okay, that is, we need to identify the internal function. Which one is the internal function?
X squared.
X squared, yes, because this is what we would calculate first. And then the external is e to the x. Yes. Then let's find its derivative. We need the derivative of the external function, e to the x. What is the derivative of e to the x?
E to the x, same.
Itself, yeah. So we e to d, but we have to have it in the place of the internal function,
X
so
squared.
x squared, and times it by the derivative of the internal function.
2x.
Yeah, x squared is the internal function and its derivative is 2x. So here I need to multiply it by e to the x squared times 2x. Okay, so again, if you have any problem with this, differentiating composite functions or a product, please come to my drop-in session and we can practice it, because you have to know this for the exam. Okay, definitely. Now, next one. Integration. Integration. We need to integrate the function 5x squared minus 8x plus 2. Okay. What is integration?
Addition.
What do you mean addition?
Means
Integration.
5x cubed by 3.
Okay.
that
But I'm asking what integration is in general. This is the opposite of differentiation. Opposite of differentiation. That is, we need to do the opposite than when we differentiate. So, similarly to differentiation, the constant multiplier remains, constant factor remains. So we have 5 times, and what happens to x? Instead of the power, instead of decreasing, now it has to increase by 1.
yes.
But at the same time, we have to divide by 3. Yes. Then,
x is to n plus 1 upon n plus 1.
yeah, minus 8
8x
times.
squared by 2.
Yes, here we have x to the power of 1. Now,
X
increase
squared by 2
By 2.
over 2, yeah?
Plus
Plus
plus 2x.
2x, exactly, because here
It's 2. Okay.
2 equals 2 to 2 times x to what power? Here, what do we have?
0.
Yes, because it is 2 times 1, which is 2. So 0 increased by 1, it's 1, and then we need to add a constant. Why do we add a constant? Why do we have to add a constant? So what did we say? What is integration? Integration is asking what is the function we have differentiated to get this function. What is the function we have differentiated so that we gain this function? What is the function we differentiated? This one. Let's see. If we differentiate this term, we get this term. This term, we get this term. This term, we get this term. And what if we differentiate a constant?
0.
Yes, that's 0. Exactly. The derivative of a constant is 0. So if I, instead of just a general constant, what if I say it's 20? Constant is 20. If I differentiate it, what is the derivative of 20?
0.
dx.
Yes, So I get the same function back. If instead of 20, I write 1,000, then what?
Same 0 is on.
It is 0 again. So I get this function back. So doesn't matter what constant I write here. When I differentiate this function, this becomes 0. So I get this function back. Okay. So please don't forget to add a constant when we have the indefinite integration. Because if you have, for example, 3 terms, then you get 1 mark for each term in the exam. So 1 mark for this, and 1 mark for the constant. So if you don't write plus constant, then you lose a mark. So please don't forget. And then the next one. What do we do now? What shall we do now?
X to the power minus 1 by 3 plus 1 divided by minus 1 by 3 plus 1.
So, first thing what I would do, I would rewrite this like this. For me, it's easier to see. Yeah, so we don't like X being in the denominator, and we don't like the root, so we would like to rewrite this as some power of X.
1 by 3.
Not just 1 by 3. That's almost.
So, minus 1 by 3.
Yes.
Yes,
So
is 1 minus.
cubic root of X is X to the power of 1 over 3. 1 over cubic root of X is minus X to the minus 1 over 3. So it equals 8 times X to the power of minus 1 over 3 dx. Integrate. And now we can integrate it. So we have 8 times X to the what power? If it increases by 1?
2 by 3.
2 by 3. But then at the same time, we have to divide by 2 by 3. So it's 3 over 2.
Yes.
And plus the constant. So this is very important. This is very important that you know that if you have such a function where you have X in the denominator or some root and you have to differentiate it or integrate it, the first step is you have to rewrite it in this form as some power of X in order to being able to differentiate it or integrate it. So, in general, 1 over X to the power of n is X to the power of minus n, and nth root X to the power of m is X to the power of m over n. Okay, so these you need to know and apply to rewrite functions like this. Okay, so please definitely know it. If you have problems with it, please practice it, because we definitely we have to apply these. Okay, next one. Integral from 1 to 2, 8x cubed.
It's 8x 4 by 4 and limit 1 to 2.
Mm-hmm. So now we have definite integration, definite integral. What does that mean? What does it give us? What is a definite integral? It means
A function lies in between 1 to 2.
Yes, exactly. So if we have a function f of x, okay, and we want to integrate it between the limits a and b, what does that mean? It means that the result, if this is a, this is b, then gives us the integral of this function between a and b, gives us the area under the curve between a and b, the area under the curve between a and b. How do we calculate that? We integrate the function, we get some capital F function, and we need the limits. And then we substitute the upper limit.
F of B.
Yes, minus
F of A.
F of A. Yes. So let's apply this. So the first step, we integrate the function. So we have 8 times
X
x
to the power
of 4
divided by 4.
Okay? Let me divide 8 by 4. So to gain 2x to the power of 4. Okay. And we write the limits. So again, the first step, we integrated the function in exactly the same way as we did before. Now, when we have the integrated function, we put it into bracket and write here the limits. And now in the next step, we substitute the limits into the function. So we have 2 times, 2 goes in place of x, minus
2.
2 times,
1.
1 goes into the place of x, which is 32 minus 2, which is 30.
30.
Okay. So what we have is that we gained the area under the curve, under this curve, between 1 and 2. So, see, when we had an definite, here we have indefinite integral. What was the result? The result was a function, right? A function where we added a constant at the end, right? So it's a function. When we have a definite integral, the result is a number because in the gained function, we substituted the limits. Okay, so one more thing. Let me draw your attention to the mistake many students commit. So sometimes what students do is they substitute the limit here into the function. Here they substitute it here and they don't integrate it. It's not good. The first step is you integrate the function and you don't care about the limit. You just integrate the function. When you have the integrated function, then you take care of the limit and write it here, and then you substitute them. So first step, integration. Second step, substitution. Okay, don't forget to integrate. Okay, because some students forget to integrate. Okay, so integration, then substitution. Okay, next one. Exercise 6. We have a function x cubed minus 3x plus 2. We need to find the critical point of this function. Critical point. Where can a function have critical points? And what are critical points at all? What are critical points?
When the derivative of the function becomes
yes, exactly. So critical points are minimum or maximum. And where can a function have minimum or maximum? Where the first derivative is 0. This is what he said. So we need to find the first derivative first. What is the first derivative of this function?
3x square minus 3.
Yes, this is the first derivative. We need to equate it with 0 and find for which axis this holds. If I divide through by 3, I get x squared minus 1 equals 0, x squared equals 1. So x equals what?
Plus minus 1.
Yes, plus 1 and minus 1, exactly. So please note, because this is again a common mistake, that when we have x squared equals something, Then we have two results, plus and minus. So plus 1, minus 1. Okay, so the function has critical points at x equals 1 and x equals minus 1. Now we need to determine whether they are minimum or maximum. How can we determine? What do we need to do? We need to find the second derivative of the function. So this is the first derivative. If we differentiate it again, what do we gain?
6x.
6x, yes. Now, please listen. Again, a mistake that some students equate it with 0 and find that x equals 0. No, we don't need to do it here. We don't need to equate it with 0. We just need to find the second derivative and then check what it is in x equals 1 and x equals minus 1. That is, first we substitute x equals 1 here. That is 6 times plus 1, which is 6. What can we conclude? That 6, what is interesting is not that it is 6 or 5 or 10. What is interesting is that it is positive. Positive, if it's positive, then the function has a minimum. The function has a minimum at x equals 1. Okay, what is the point then? What are the coordinates of the point? See, we are in the plane, and in a plane, every point has an x and a y coordinate. X and y coordinate. A point is given when both the x and y coordinates are given, not just one of them, when both are given. We have the x coordinate, it's 1. What is the y coordinate? How do we get to know? How do we get to know? This point is on a function. So this is the function curve. This is the x coordinate. What is the y coordinate? How do we find the y coordinate of the point which is on the curve?
We can substitute in f of x.
Exactly, yes. So this is the original function, f of x, because what is f of x? With other words, it's y. So y equals f of 1 in this case, because x equals 1. So I substitute, I get 1 cubed minus 3 times 1 plus 2, which is
0.
0. So the point is 1, x coordinate is 1, y coordinate is 0. So please note that this is how you have to give the point. And for this you get full mark. Okay, so you need to give the point like this, that is with x coordinate and y coordinate. How do you get the y coordinate? You substitute the x coordinate back to the original function f. Original function, not the derivative, the original function. Then the same with the second, minus 1. We put it into the second derivative. It's 6 times minus 1, which is minus 6. This is, what is interesting is that it is negative.
Less than 0, maximum.
Yes, its function has a maximum. Again, we know that x equals minus 1. We need the y coordinate, which is f of minus 1. That is minus 1 cubed minus 3 times minus 1 plus 2, which is 4. So the point is given as minus 1, 4. Okay? So in 1, 0, the function has a minimum. In minus 1, 4, the function has a maximum. So this is how you need to give the points. I'm emphasizing it because students often forget to find the y coordinates. Okay, so this is how you need to write it. Okay, again, it is a very important exercise. Okay, so this you need to know. Important exercise. Next one is exercise 9. Use the gradient descent algorithm to find the minimum value for the cost function f of x equals x squared. Perform 2 iterations using the gradient descent algorithm. Suppose the initial value is given to be x equals 2 and the learning rate is set to be 0.01. 0.01. Okay, let's do that. Maybe I need a new page. So we have a function f of x equals x squared. The initial or old value of x is given, it's 2, and the learning rate is given 0.01. Okay. The first step we need to do is we need to find f in place of the original value. So f of 2. That is, f is x squared, so we have 2 squared, which is 4. Okay. Now, we need the derivative of x. What is, yes, 2x. So first, we substitute the original value into the function. Right, we calculate it, first step. I'm emphasizing it because students often forget this step. And we find the derivative. And now we can do the first iteration. We need to find the new x. How do we find the new x? We take the old x, which is given, minus learning rate, which is given, times the derivative of the function in the place of the old x. So we need to substitute the old x into the derivative. That is, old x is 2 given, minus epsilon is 0.01 times, derivative is 2x, so 2 times, what is x? X is 2 because it's the old x. Okay, so it's 2 minus 0.04, so it's 1.96. This is the new x. Okay, again, important because students often forget, we need to substitute this new x to the function and calculate it. That is 1.96 squared, right, which is this. Don't forget to calculate the function in place of the new x. And now we do the same again. Second iteration, we want to find the new x. Now we need to take the old x. But what is the old x now? The old x is the new x which we gained here. So this new x has grown old here. Yeah, it has grown old very quickly. So this minus 0.01 times derivative 2 times, and the x now, this is the old x.
0.96.
Yes. And this becomes 92. So this is the new x. Now, what again we shouldn't forget to substitute this new x into the function. So 1.92 squared, which is 3.68.
And we have to multiply 0.01 in both, I think 2 and 1.96.
Yeah, here. Yeah, what?
From in the second last line. If second last line,
yes,
I think we have to multiply 0.01 in both set 2 and 1.96.
It's one term only.
It's just one time, because if you multiply it twice, then you multiply it by 0.0001, or maybe even one more.
Yeah, yes.
Right? So just once. See? Epsilon, just once. And then, because this is the derivative in place of 1.96. So this is this. So you have to multiply it just once.
Okay.
So we check the function value. Here was 4. Originally, it was 4. Then here it decreased to 3.8. And now it decreased again to 3.6. So it really decreased. Again, important exercise. You need to know this. So if you have any problems, any questions, please come to my drop-in session on Thursday, tomorrow at 1 o'clock. Okay? And through MS Teams. Otherwise, see you on the next tutorials. Okay, so if you have any questions either with this tutorial or the previous tutorials, tutorial sheets, please come to my drop-in session. Okay, so see you guys then.
Thank you.
Sure.
Thank you, ma'am.